All right, everyone. We're ready for our next talk, so please take your seats and quiet down, please. And quiet down, please. Please stop talking. All right, so our next talk is on Starling Monkey and Componentize JS by Guy and Till. Please welcome them.
Good morning, everybody, or afternoon, evening, night, whichever it might be. So Guy and I are going to talk to you about Starling Monkey and Componentize JS, two projects in the Bytecode Alliance. The second one fairly recent. Starling Monkey is, I guess, only a few weeks now, an official Bytecode Alliance project. And we'll talk through a bit about of what the projects are, some slight context how they came to be and how they relate to each other, and also what we're planning to do in the future going forward. And so I'm Till Schneidereit. I work at Fermyon and started the Starling Monkey project twice in some ways. I will hand it over to Guy to talk about roadmap things first.
Sure. So I'm working at Fastly on the JS compute and have been collaborating with Till on Starling Monkey for when did we start it? Last year or this year?
Last fall, I think. Yeah.
It's been a while in the making.
Yeah.
I'll just switch over to the slides here. So what is Starling Monkey? It's as Till mentioned, it's recently a BA project, and it's effectively like what we call this Winter CG compatible JS runtime. So you get a lot of the expected web platform features that you'd want out of a modern JS runtime, and we implement all of those compatibility layers based on the SpiderMonkey JS engine, and a build of that SpiderMonkey JS engine for WebAssembly supporting all of these built-ins. And you can support these built-ins in a modular way. So you can create your own custom build. So it's like build your own JS runtime and select what platform features you actually want to use. And so you can do the absolute bare minimum and just have like the minimal SpiderMonkey JS engine, or you can include the kitchen sink and you've got something that's getting close to like a full Winter CG environment. We also have this host API abstraction layer so that we have initially Till provided this for multiple versions of WASI. So we can simultaneously support versions of Preview 2, but now we can do Preview 2, Preview 3, and have different host versions. And we can also support other host environments that aren't necessarily fully compatible with Preview 2 as well. So to give a very brief status update on the project, it's now shipping fully in production at Fastly and Fermyon. So as of the version 3.20 of Fastly's JS Compute at Edge, it's fully built on top of Starling Monkey. And I don't know if you have a brief update still on Fermyon's shipping of Starling Monkey, or has that been for the past few months or for this year?
It's been, so we announced a new version of our JavaScript SDK, which previously was based on another JavaScript engine, QuickJS. And now we have a new SDK, I think, since a bit more than a month, maybe a month and a half or so. That is also based on Starling Monkey and kind of replicates the previous API for backwards compatibility, but also enables the kind of Winter CG compatibility aspects.
So I think it's a really key point about this project is that it's an experimental new BA project, but it's running in production. It's got production users at these companies. And I also refactored Componentize JS to be built on top of Starling Monkey, so that you get the same kind of set of features in the Componentize JS project when you want to dynamically target world bindings. And to give an idea of where the project is in terms of compatibility, we're actually running the full web platform test suite. And as of today, it's 15,552 tests passing out of 17,000 that we run. We only run the tests across the subsystems that we support. So everything from web crypto, compression, console, encoding, fetch, streams, URL, structured clone timers, those kinds of things. But compat remains a work in progress, but we are already tremendously far along. Another announcement we can make is traditionally, and various SpiderMonkey projects had their own T-shirt designs with this artwork by John Howard. And Luke was able to work some magic, and we have just got a Starling Monkey T-shirt design. So you can look forward to these. You can look forward to, hopefully it sounds like we've got some BA budget for it. Hopefully at WasmCon we should have some T-shirts. If you're not going to be, or Till, if you want to mention anything on it.
Yeah, we have budget approved for this. The exact details of how many shirts we'll order and how we will distribute them, that's all a little bit TBD, but there will be Bytecode Alliance Starling Monkey T-shirts, which I could not be more excited about. That's really, we can end the talk now.
Yeah, this is the only reason we're speaking, but this isn't public yet, so please don't share it too widely.
Except for the YouTube live stream we have going on.
We'll just ignore that. And another major update we have recently for Starling Monkey is Chris Fallon's performance work, which is now landed in the Starling Monkey project. And this is, more than a year's worth of work on compiler optimizations. And Chris has done a fantastic job of writing blog posts and updates all along this journey. And it's literally ended up as a make it fast flag. You can just add the flag, and it makes everything 2 to 3 times faster. We've seen that consistently in Fastly across various customers for compute-heavy workloads with independent verification.
Yeah, we've seen it too. These numbers are surprisingly robust.
I was surprised, but the trade-off is, of course, a few extra seconds compilation time and an increase in binary size, but we haven't found that prohibitive. Chris has some excellent blog posts on the topic. His latest blog post was part 2 and part 3. I would highly recommend reading those if you have a spare hour or so. But it's absolutely phenomenal work that's now has first-class support in Starling Monkey. So I'll pass it over now to Till to give some updates on the upcoming roadmap.
Yeah, so there are a few different items I want to talk through. One to start with is Rust built-ins. And so allow me to talk poorly about a past member of the Fastly WebAssembly team for a moment. Before you get upset, it's me, I'm the problem. I built the precursor to Starling Monkey, the JS Compute runtime at Fastly by now, starting 2.5 years ago, I think. 3 and a long time ago. And the Rust bindings for SpiderMonkey were not in a great state at the time, not really maintained, and I kind of didn't want to take on the complexity of getting those up to speed. And so I started using C++ for this. And there are many, many things in the world that I should be doing more than starting a JavaScript runtime in C++, but here we are. We now have a C++ runtime still in JavaScript runtime in C++. This was confusing. I have a PR open, PR 103, that will add support for building parts of the runtime, so built-ins to start with, but really any parts of the runtime in Rust instead of C++. You can basically say, well, you get out a static library, and you link that in, and whatever it adds, it adds. The idea being that there's a very light sort of lifecycle model where you can register additional global object built-ins and so on. And then the idea is to, after this, actually kind of swap things around to go from a C++ runtime with Rust support to a Rust runtime with C++ support, because I don't think it makes sense for us to port all of the existing C++ code to Rust. That would be nonsensical, pass a lot of tests and so on. But going forward, I want to mainly focus on using Rust for both additional built-ins, but also the runtime itself, including for things like the WASI P3 support and so on. And migrating all internal built-ins is a goal, but not by necessarily porting the existing code as it is, but potentially for many of these things, we'll actually be able to do away with our own implementations and start adopting upstream implementations from the Gecko project eventually, which will also lead to really high quality and kind of as compatible as it gets implementation for a lot of things. Debugging, completely different thing. This is not Rust code, so it doesn't work when it compiles. Joking. One of the big missing things always is debugging support. And even if we add kind of high quality dwarf debugging support, in addition to the baseline we have right now in Wasmtime, that doesn't help us, because you don't want to debug SpiderMonkey or Starling Monkey. You want to debug your JavaScript code. And so there's an accepted RFC in the Bytecode Alliance for adding full support for component debugging, including high-level language debugging, with, I think, a very, very good setup in Wasmtime. But fully going into doing that will be a lot of work, as Nick talked about yesterday. B, we actually are interested in debugging these components, not just in Wasmtime, but also in other implementations. And so Dirk and from Microsoft and I have been collaborating on a kind of very low-tech in-content approach to start with, which we will then be able to bring closer and closer to an ideal component debugging story that will eventually, I think, have a good basis for also being used in other for other languages. The idea basically being that, to start with, we implement the VS Code debug adapter protocol, widely adopted by other coding environments by now, in content as part of Starling Monkey, and then and in terms of SpiderMonkey's internal debugger API, and then we can from there move it into its own debug adapter component that has a WIT interface that exposes basically the DAP via WIT, and then that becomes a thing you can implement for other languages. And then we can kind of move from that WIT interface, which is sort of an ad hoc, non-standard thing, to something that we actually at least have conventions around. And now it becomes a reliable, maybe eventually there'll be a WASI DAP, I don't know. And then that can become the basis for more broad component debugging. But right now, this is kind of pathfinding and very much focused on Starling Monkey itself to get to an initial version quickly. And then WASI P3 support, Luke and Joel talked about this. We'll start experimenting with this soon. There's this interesting point where right now, if you run an event loop inside a component, you have to fully run it internally, and it is not really composable with other things easily. And so you start, you have your main function by whatever name, could be the incoming event handler for an HTTP request. And then once you return from that, you return from it, and there's no more event loop. And we'll keep that structure in the first iteration of the WASI P3 support. WASI P3, as Luke talked about, has the ability to either kind of do the same sort of EPOL-like, hey, I have a list of tasks, wake me, or return from this blocking call when one of them is ready. Approach to async task handling. We'll switch experimentally to that as soon as there is kind of up-to-date runtime infrastructure for it. And then as a next step, we do want to also have the ability to switch to a model where we actually return from our main function and let the environment call back into us with the callback-based async API, which would have nice advantages, but for now is that'll actually require us to change the host API in ways that aren't compatible just because the lifecycle model just is somewhat different. I'm for now very much looking forward to adopting the first part of this and getting kind of a testing ground for P3 going in Starling Monkey. And then, do you want to talk about Componentize JS upstream?
I can discuss that. So there have been some questions about the future Componentize JS, since it was refactored to be based on top of Starling Monkey, and it shares a lot of Jco internals. It kind of sits between the two projects and gets tested closely with both of those projects. So we've been wondering if it makes sense to upstream Componentize JS into Jco or upstream it into the Starling Monkey project, and there have been discussions on either side of that. I think one of the kind of interesting arguments that I heard from one of our users was that if the Jco project is including all of Starling Monkey and all of the Componentized JS functionality, for those who are only using it as a host side component integration project, it creates it includes code that they don't necessarily want to audit as part of their dependency tree and include and pull in as part of their dependency tree, which I think is a really interesting argument for looking at upstreaming Componentized JS into Starling Monkey entirely. And it also seems to align with the use cases for Starling Monkey, where you typically will want to use Starling Monkey to create components, and you'll want bindings for arbitrary components against Starling Monkey. So moving towards a first-class experience for componentization in Starling Monkey is the current direction we're looking at. It's going to be a bit of a process, but ideally, there is other work going on in Starling Monkey around a CLI experience. So if we could integrate it either into a Starling Monkey CLI or a Starling Monkey related NPM package, then it should just be an upstreaming that can fit into that process. And then the Jco project would remove Jco Componentize and focus entirely on the host side. So you'd have Starling Monkey for the guest side and Jco for the host side. And where the Jco bindgen is shared, Starling Monkey can still depend on Jco's bindgen crates, etc. So that is the current plan. If anyone has any thoughts on that or is interested in discussing that further, now's a good time to have those discussions, since we're just starting to make those directions. And then Till, did you want to discuss the CLI side of things?
Sure. So and then you'll do the REPL, you mean?
Or
right.
Either way, go for it.
Okay. Another thing I have been working on actually as preparation for the debugger work is giving Starling Monkey a CLI, which is kind of interesting because in Starling Monkey isn't typically, or in many cases, it's not called as a CLI with a main function that actually gives you an argv argc pair, and instead it's often called under Wiser, where it gets so far it got the file name of the file to load as the top level script passed in as this string to read from std_in. And so instead, what a PR I've opened does is make it so that it has multiple ways of applying parameters. One is to take a string, split it into argc_argv, or actually a vec of strings, and or it can take that vec by if it's called via main, and it can also be initialized from environment arguments, variables. And then there's this custom arg parser, which I didn't put too much work into because really that should be a Rust grade. And so once the Rust support has landed, that's what I'll want to use. And but the idea is that we can then expand on what kinds of arguments we can pass, and I think that'll help with the Componentize.js integration, because in some regards we are currently in Componentize.js working around some things where we don't get information out, or where we don't have a good interface mechanism with Starling Monkey, and having a CLI interface that allows us to say, hey, run in this mode and give me back this information will be useful. It also switches to a way where you can generate an uninitialized component and can run that with a pre-opened directory and either pass in configuration via a well-known environment variable, or it will load an index.js file from the directory to run a script. That's very useful for development mode, where you don't want to recompile, you don't want to recomponentize, you want to be able to hit reload, and on every request you actually get whatever the index.js file is. So the kind of thing you would expect. It doesn't make sense to run in production, but it'll be good for development cycles. And some of the refactoring required for this will also help with the grapple experience. And you did talk yesterday to me about some ideas you had, so I'll actually pass it off to you for the grapple.
Yeah, so I think I'll maybe bring that more up on the 1.0 roadmap, but I think we want to have a really good getting started experience for Starling Monkey, where it's very easy to test it out and see it in action without having to download J-code, download Componentize.js, download Starling Monkey. There should be like a unified beginner experience for Starling Monkey to be able to start playing around with it without having to build your own JS engine, even though that is the primary use case.
For WinterCG compatibility, I just this moment realized not everybody here might necessarily know what WinterCG even means. It's the Web Interoperability Community Group under the W3C, and it's basically, which Guy is a member of, and it's basically a group of outside the browser vendors looking at what are the web standards that we want to support as kind of a baseline of interoperability for a unified JavaScript ecosystem across outside the browser and in the browser use cases, and also where are the gaps in the web standards for what you need if you run JavaScript outside the browser. There are some limitations browsers apply or enforce around HTTP requests, for example, that you kind of fundamentally have to lift for outside the browser use cases. So it's not actually meant to be, we are all a group that is agreeing on doing what browsers do, but more we are agreeing on trying to achieve maximal interoperability with the web ecosystem, while also kind of working through the specific requirements that apply to outside the browser use cases. And part of that is a spec document outlining a list of APIs that are seen as kind of the common interoperable set, and a test suite, or I guess part of the WPT suite, so web platform test suite, that tracks compatibility with those. And as Guy talked about before, we do have a high degree of compatibility with the API, the parts of those APIs that we do support. We don't support all of them, but those that we do support, I think we're doing very well on. And Guy recently put together a GitHub project board tracking efforts to drive that forward and increase both pass rate and coverage of the web platform test suite. Things you want to add to that?
Yeah, I think it's a process of keeping up. Things change all the time. Currently, the Winter CG in itself doesn't have the ability to create standards. It's just a working group. And so they're currently working through how they can become a formal standards body. And one of the things that has been happening recently is there's been engagement within the ECMA group, which is the standards body behind TC39 that specifies JavaScript, to be able to figure out a shared standard space where WinterCG can exist and create its own standards. And there's a whole bunch of IP questions about that, of how you balance that between the W3C and ECMA. But that is being worked through currently towards the goal of being able to formalize these standards, formalizing the common minimum API, formalizing the differences, and having formal test suites and things like that. So keeping up with those developments is a constant initiative for the project, and something that we continue to plan to do. And as Till mentioned, that we've got a project board together tracking the common minimum API, and it's very much one of the primary goals of the project is to keep on top of what is this Winter CG compat, as well as other types of compat, which brings me to the next slide. The other side is that if you want to run standard JavaScript applications, they often rely on Node.js libraries, and you can polyfill them with build tools and approaches that'll support those JS features. But we can do it much more efficiently if we can support native implementations of the Node APIs. So all JS platforms to date have started off in their own little islands and then ended up implementing Node.js compat. You see the same story for Dino, you see the same story for Bun, you see the same story for Cloudflare. And I think we know that that's the story, so it's just on the roadmap. It's not something that we're actively working on yet. And maybe once we have the Rust built-in toolchain together, it would make a lot of sense to implement in a Rust toolchain. But especially when we're running a WASM runtime, we don't want all of these compatibility layers to be in JS. We want to have them well authored and optimized, so that when you're using these Node built-ins for buffer or Node streams or Node HTTP, we've got the most efficient binding of that against the WASI APIs. And so this is very much a future goal for the project, and something that we're tracking closely. There's also efforts within the Node.js project to abstract the test suite, in line with the fact that a lot of projects want to run Node's tests these days. And so we're also following those kind of efforts, and ideally we'd be able to, in due course, check in the full Node compat test suite and be testing against that.
One kind of nice advantage we have here is we don't even need to implement all of this local to Starling Monkey. In particular, once we integrate Componentize JS into Starling Monkey, then we can implement a lot of this as separate components with binding or with interfaces that we generate bindings for, and then kind of talk to that. It's not the right approach for kind of very chatty low-level interfaces, but for that are kind of needed everywhere. But for long tail or big items that are nicely encapsulated, that might actually be a nice approach. And then we have towards 1.0. Which do you want?
Yeah. What did we put on this?
We're exceptionally well prepared.
Yeah, we completely went through these slides together. So yeah, the 1.0 release of Starling Monkey is upcoming, and we see this as an important release milestone. There's an opportunity to get the project to a point where it has a really seamless getting started experience, and if we can really get the core messages across of the security, the performance, the WASI story, the modular built-ins, the WinterCG compat. There's a lot to talk about there, and there's a lot to build interest on. And so we don't need to achieve all of the roadmap to do the 1.0, but we need to just polish things out, have a really nice experience of like, if someone tests it out and writes a fetch handler and they fetch something locally, it should just work, so that we have that like very basic expected experience. But if done well, it would be really great if we could make the project really popular.
Yeah, and the best way to get there is, of course, to get as much help as possible. Documentation is a thing I want to call out where we're not doing great on. So that would be a fantastic thing to improve. Overall, also examples, well, I want to say paper cuts, but it's probably more knives hidden here and there right now. So making overall, yeah, the experience of using it match what I think is actually a pretty high degree of maturity of the implementation. And that is really what I think is missing for 1.0 and for starting the process of making it popular and making it one of the highlight projects of the Bytecode Alliance, which I think it can and should become over, I don't know, the next couple of years or so. And that is all we have. Thank you all.
Are you willing to take questions?
No.
No.
Yes, by all means.
All right. Any questions here or online?
I'm just curious if you have any performance data, so compare with probably the Node.js on the same platform. I'm just curious about the performance.
Performance is a notoriously difficult thing to compare, as you do not know. There are, a guy we explained the Weevil project, giving it 3x up, speed up. What does that mean? Where are we now? And the answer very much depends on your use case. If you have a use case where, as many of us working on this in many cases do, where you do something like you request or you have an incoming HTTP request or event of any sort, and you do some lightweight compute on it, look at a few headers, modify them, maybe filter things or so, and then pass request on, then our performance is actually amazing. If you do something like render a very complex React template that takes, say, 50 milliseconds in a fully warmed up JavaScript engine, kind of industrial strength browser JavaScript engine, then that will, so it'll probably be 30 times slower or so. Because we don't have a JIT, we don't have the ability to look at what is the code actually doing, what at runtime in this particular execution path, or the same path all the time because it's the same React template being rendered. So we can tap specialized types, you can inline and so on. That is something where we have future approaches on more than concepts of a plan, but it's also not a fully described plan. And it is a whole bunch of engineering work that needs to go into it. But we do actually have the advantage of being able to do short running code in a time frame where other engines, because of how they are structured, have not even completed starting up yet. And when we are done with processing the event, and that's not an exaggeration. That's kind of the normal.
To give an example, Node.js has multiples of 10 milliseconds startup time, while these engines can start up in microseconds.
Yeah. So
and you're skipping all the JS initialization, so you're not hitting the file system. You're just at the point of serving the handlers. So the warm starts are a major feature of it.
We also have Chris Bond with his hand raised online who can speak to performance.
Yeah. So Nick asked me to maybe say some things about perf as well. So to answer this question, I would encourage anyone who's curious about perf, first of all, to read my blog posts. I talk a lot more about the trade-offs that Till and Guy just mentioned. But there's sort of something fundamental about the request isolation model here, which is driving like the alternative approach, right? So like, as I think Till mentioned, we in Node.js, native JITs can basically observe and specialize over time. And you have, once warmed up, essentially native code that's like optimal, right? Like it's specialized to the observed types, it's specialized to the object shapes. And fundamentally, we just can't do that. So competing with a JIT is going to be hard. We're never probably going to get to the performance that like V8 has once you're warmed up. That said, there are ideas that we have to get closer. So one sort of follow-up work. So we do AOT compilation on the level of what a browser engine would call baseline right now, which means that we have ICs, inline caches, and so we still have some runtime indirection for the specialization. And we have ideas around a thing that we're calling cloud PGO that's basically profiling over time as execution happens on mini requests and trying to recover sort of that like cross request specialization by doing semantics preserving inlining in the WASM. So the idea is that it's still safe in the same way that like everything is like sandboxed and safe and dry from the interpreter today, but it could allow us to sort of dig further into that like 10 to 30x gap that still exists. So there's a lot of work here just because fundamentally we're, competing with the JIT that's been optimized with engineer centuries of work. And the different sort of requirements mean that we can't take the same approach. But we have ideas to try to sort of still improve. Yeah, and I'm happy to answer more questions on Zulip if folks want to dig into like what the performance trade-offs and questions here are.
I'll add also the blog posts that were referenced during the slides and by Chris just now have been linked in the Zulip in the Fast.js on WASM blog posts topic in Summit September 2024 stream.
And one thing I just realized while we were all talking about this topic is that we haven't talked about a thing that we've, I think, been taking for granted for way too long, but probably not everybody is familiar with, the idea of taking heap snapshots of initialized applications and then being able to run, kind of hit the ground running, processing individual events. And that is based on a project Nick started a few years ago called Wiser, the WebAssembly initializer, which takes you from an uninitialized component or back then module to a initialized or wizened component that has and the idea is Starling Monkey obviously by default doesn't contain any specific application code. And when you first invoke it, you invoke it via the Wisening export, and that reads the file, evaluates it, parses it into bytecode, and then executes the top level. So it actually runs the initialization part of your application, and that registers a handler for the incoming request event and so on. And then we take a snapshot of the heap as it is at that point, bake that into a new WebAssembly file that Wiser emits, and that is what gets deployed. And this is not a heap snapshot. So V8 has this concept of heap snapshots, but that actually only supports built-in JavaScript things. You cannot invoke any APIs that the embedding might add, making it very limited in use, but also these snapshots have to be deserialized. That's not how our snapshots work. They work as a literal snapshot of the heap as it is, which we can do because of the WebAssembly sandbox. It's kind of this tightly isolated space of memory that will always have the same offsets and so on. And that allows us to make it so that you get, for example, an HTTP request incoming, and then we, I don't know, read an env or two in C++ code, in the future Rust code, and then we call the JavaScript function you registered at the event as the event handler, and that is it. There's no further initialization happening. And so the tens of milliseconds of node startup time or the 5 milliseconds of Cloudflare Worker startup time, those are always numbers quoted until the first line of content code is being parsed and then executed. That's all not part of the startup path we have here. This is has all happened before any byte went to the network from the developer's machine. And that is, and Wiser actually was built specifically because otherwise we could not have effectively used JavaScript to process events in the lifecycle model we're pursuing.
Your JS at the top level is basically a compile time JavaScript execution.
Yeah.
So you've got sort of 2 times that the code is running. And if you think of traditionally in Node.js, if you're importing a server and then running it, you've got to go to the file system, fetch all the modules for that server. We do all of that at compile time. So the whole module graph is loaded in, and then you just create a full snapshot of the application once it's listening to the server handler.
I should note this is not specific as a thing you can do to JavaScript. Wiser works for arbitrary languages, doesn't know anything about languages, works for Rust, works for Go, works for whatever language. Componentize Pi, similar equivalent to Componentize JS project that Joel Dice started for Python, is using an equivalent to Wiser that is fully focused on components called component init, and that too can be used to kind of pre-initialize arbitrary components. And so you can do nice things such as initialize regular expressions, which typically are kind of runtime initialized in most in most languages, and then you have the high performance regardless of how many regular expressions you have in, again, also for each event, and you don't have runtime overhead, which that is kind of, I think, an underappreciated part of the isolation model WebAssembly provides, that we can do this kind of thing in language agnostic ways and without having kernel magic and hard to manage systems with themselves a lot of overhead and startup times and so on. Any other questions?
All right. Thanks again to Till and Guy. So now we will have a break until 11:15, in which we'll return and Brett will give a talk about Python. So yeah, see you then. Hey, do you want to maybe do a quick setup before we're
Should really be doing.